in order to talk about primitive types, we'll be using RexTester to provide some examples. So before we get into the types, let's talk about variables and constants, as we will need these. So variables, variables are something you declare once throughout the program, and they can be changed throughout the program. So variables are declared once and can be changed later on. And then we have constants. And constants are declared once and can not be changed later on. So this is declaring a constant. We'll begin with the keyword const, and then let's say an integer, and then let's just declare a simple integer up here. But first, let me explain the naming conventions. Naming of variables or constants. So this is how you want to be naming your declared variables. So pretty much they have to start with a letter, and then they can be followed by either a number or an underbar. So let me declare a simple integer. So int, my int is equal to 1. You can also declare it by saying int, my int is equal to 2. And then you can also do int, my int 1 is equal to 3. So these are all possible ways of declaring something. Pretty much. So let's also do that with our constants. However, I like declaring my constants in all caps because they stand out and you can tell which item is a constant or not. So let's say a const int, and then this is equal to 100. So these are all possible declarations of your integers, or whatever you're declaring. So those are the basics of how you can declare items. They have to start with a letter and then followed by either an underbar or a number. These are possible. They don't have to, but they can be. So can be. So now let's talk about our primitive types. These range from. So let me write them down. I'll be doing int, float, character. Let me throw in double right after float. And then the most simplest of them all is Boolean. So let's go through an integer. So ints by default are 32 bits and can hold numbers from, it's a big number, so bear with me, negative 2000, excuse me, that's not 2000. I think it's in the billions, 483, and then 648. To positive, okay, this number, I don't know the exact way of pronouncing it, so I'm not going to try. And then 647. So that is the range of what an integer can hold. It is by default signed, which means it can have a negative numbers, as you may see. So, let's do a constant and a non-constant of it for all of these. So let's do int and int is equal to 1, and then const int the constant in, let's say, is equal to 2. So that's pretty much an int. That's pretty much what it will be. So let's move on to a float. So floats are by default 32 bits as well. And they can hold approximately negative 3.4 times, let's see, I think it's 10 to the 38. 8, and then to positive 3.4 times 10 to the 38. So a pretty big number. So how we declare these is same thing, float. A float is equal to 2.56, and then f, because they have to be followed by f. So let me write it down. Or ends with f. Otherwise, it will assume it's a double, which a double is just a much larger version of a float. And a float also has is accurate to 7 decimal units. So 1, 2, 3, 4, 5, 6, 7. So that's about as accurate as we'll get. Then constant float my float equal to 2.1415, so on. So that's a float. Let's go with a double. They are 32 bits, so these are, 64 bits, hence them being larger than a float. Let me write it here, decimal. So there are 64-bit decimals. These hold a very, very, very large number that I will not write. And they are accurate to 15 to 16 decimal units. So double, let's say a double, 2 point, something. These do have the option to end with an F. They don't necessarily have to, but it's a choice. But I wouldn't. It's not necessary. It's just it's possible. Then my double. And then there you go.